everyone. In this video we are looking at the 2010 ordinary level perspective projection question. Now it is a tent, hollow on the inside, two sloping roof surfaces and a window which is vertically open there so you can see into the tent.
So here I have my plan set up. I have S, I came down 70 millimeters from A to get it. 30, 30, 20, this is 90, 3/30s to set it up. The picture plane is touching corner A. So my first job is to get my cone of vision. And bisect my cone of vision to get the axis. I'm going to draw my axis quite high because I will use that to measure the distance between my ground line and my horizon line, seeing as it's going to be perpendicular to both of them. Let's see if I can use my adjustable here. Just about. So that's my picture plane passing through corner A. My ground line. My horizon line is 30 millimeters above my ground line. And I'm just extending these lines because I don't know how long they're going to need to be. So there. I'll get my vanishing points by looking parallel to the lines. So these lines, I'll see where they vanish if I look parallel to them. That's one vanishing point. Same in the other direction. I'm going to see where all of these lines vanish if I look parallel to them. There. Vanishing points will be on the horizon line. And I'll just label what I have. I have my picture plane, ground line, horizon line. VP1, VP2. So A is on my picture plane. A will be a true height, but the only thing I can use A for true heights, for the true height of, is anything that could be contained on the same plane as A, the same vertical plane. So a vertical plane going this way, I can use heights on that at A, or a vertical plane going this way, I can use for heights from A. So that basically means everything except the dormer window that's at the top of that roof. Tent, apparently it's a tent. Okay, so my heights that I can use are 15 and 65. So from A, I can go up 15. And from the ground, I can go up 65. So there to there. Now my 15 is relevant in both directions. So the top and the bottom of my 15 can go back to VP2. My 65 is only relevant in this direction though. So my 65 is going to go that way. Now I'll get the outline of the base by projecting up where those lines stop. So this edge keeps going back to that vanishing point until it stops here. So that point back to the spectator where it cuts the picture plane, bring it up. And that's the end of the base. And in the other direction, that's my point where it stops going back at that angle. Bring it up, and that's where that is. I'm going to go over that bit in heavy so that we don't start getting confused with the lines. So the back surface, I have a vertical line here. I have my corner A, which is a true length. And I have my back corner here. This is all a vertical face on that side. But on this side, my surface is separated between a vertical face and an inclined face. Inclined just means at an angle, so I have a heavy edge there.
To tie that in with our 3D model, we can see how we set up our cone of vision, got our axis to it, and our picture plane would be perpendicular to the axis of the cone of vision. When we put in our picture plane, we have our spectator in plan there and looked parallel to the edges to get the vanishing points. So just to remind you that your horizon line is the same height as your spectator, and all horizontal lines vanish on the horizon line. Now in these ordinary level questions, we don't have auxiliary vanishing points. So all of our vanishing points are on the horizon line. Now we got our lines of vision there, and you can see the points on the picture plane where the lines of vision pierce the picture plane. And we've got the vertical rectangle on the right. You can see where those lines of sight pierce the picture plane, and our true height line is vanished back to both of our vanishing points on the picture plane. So we just found that vertical surface and filled it in.
Now my apex, which will be on that height line, I need to find it by joining it back to the spectator. So this is where my apex is going to be. Back to the spectator, it cuts the picture plane, take it up, and obviously it's going to appear smaller than it actually is because it's behind the picture plane. So I've got my height for it, and I'll get my slope just by joining the dots. There. This line from my apex is going in this direction. That's me looking parallel to it. So this line is going to come back to VP2. It'll stop coming back to VP2 here when I find that point. So him to the spectator where he cuts the picture plane, take him up, and that's the back of my roof. I'm going to keep that light for now because I'm not sure what I'm going to see around the window.
In our 3D model here, we can see that A was used for a height line, and the apex of the roof is on a vertical surface that A, my corner A, is a part of, so it can be used for my height line for the apex of the roof. It's on the same plane as A, so the height can be marked off directly above A. Now that height is then vanished back to VP1 because it was the blue surface that the height was on. And I can complete the roof using that height by vanishing it back to VP2 in the other direction.
Now the window is not on any of the surfaces that are connected to A, so I'm going to need a height line for the window. And what I really need is the height from here to here for my window. I know the width of it, but I want to find the height. So I'm going to extend a plane and say that the plane that I am extending contains the front opening of that window. So I'm going to extend the plane this way. And I'm going to use where it cuts the picture plane as a height line. Now a height line is something that we're saying it's a true height. We have a vertical plane going as far as the picture plane and it's touching the picture plane there. So that means that this height line will be going from the ground up. And the heights relevant to my window are if I go up 50 and up 65. So from my height line, sorry, up 50. There, and my 65 is on the edge anyway, so I don't really need that. So I'll just highlight my up 50. There. The height line that I extended was parallel to me looking in this direction, which gave me this vanishing point. So I'm going to take the top of that height line to this vanishing point. Now that was my height of 50, which was this horizontal line. I'm going to find these 2 points in order to get the top surface of that window. So these 2 points are coming back to the spectator. And at this point, you might want to highlight some of your lines. So where my 2 yellow lines cut my picture plane, I'm going to take those up to the ridge of the roof. That's one. This is my other one. So there's that point and that point. The front surface, the line that is actually on that height line, back to the picture plane here and here. That was my first corner back, is going to be on this line. Which is here. And my second line back is on here. There. I'm going to put that in dark. So that's my horizontal line at the top of the opening for the window. That is the sloping surface at the top of the window. And I'm going to put the ridge in heavy. Now underneath that window, if you were to line up and plan, you have that line that's at the opening of the window. That's a point in plan. So that means that if the line is a point, I'm seeing that surface as an edge. The surface that I'm talking about is the opening here. That surface is an edge view and plan. Now, if it's an edge view and plan, it must be a vertical surface. So I'm going to find where this line is. Remember, I didn't draw an elevation. It's hard enough not to remember when it's not there on the page. But anyway, I want to draw a horizontal line on my roof in plan that would line up with the base of that window. So in 3D, I'm doing this. I'm going to find that line on the roof.
These height lines are very important to be able to visualize what you're doing. So that window isn't touching any surface that's touching the picture plane. So I can't use any height line. I have to make my own height line. So when we extend a line in plan, that line actually represents a vertical plane, and the heights that I'm looking for are on that vertical plane. So you can see the transparent vertical plane there. It's after being extended until it touches the picture plane. And where it touches the picture plane, I can use that edge as a true height because it's on the picture plane. Now the top of that height is the same as the top of the opening of the window. The plane I extended was parallel to me looking in the direction that gave me VP2. So the top of that height line had to be vanished back to VP2. You can also see in plan there, I've drawn a line on my roof surface, the black line running along, that's going at the same height as the base of my window. Where it hit the edge, I projected that back to my spectator, and where that cut the edge of my roof in the perspective, it went back to VP2, and that gives me the line that my window is on.
I already have that line drawn in terms of a height line, but it only exists as far as the edge of the roof there. So I'm going to do it in colour at the risk of accuracy, just so you can see it. That's where my line cuts the picture plane. So just a line on the roof that the bottom of the horizontal section rests on. So I've taken it from the edge of the ridge in perspective here. It's a horizontal line, so I've taken it from here up, and it's hitting the edge of my roof there. So that line is there in my perspective, and I know that these 2 points are going to be on it, and those 2 points are going to be directly underneath these 2 points here. They're on the same lines that I took back to my spectator, so directly underneath this, as far as my pink line is the opening. So there. These two are joined, so we're looking back at our 3D view. And this time we won't get caught by the fact that our window is actually open, which means I'm going to see another little bit of detail. This second, the triangular vertical surface I'm also going to see, which is here. And I wonder, will I see anything else? I'm going to just get what's inside here. I'm just going to get the base, just in case there's any other edge that I can see through that hole. So I'm going to take my front corner back, where those two lines meet at the back. That's my back corner. I'm going to take this back corner up to here. That's the back of this point. So this would go to my apex. So that is the back of that line, and I can see a little bit of it in there. Which is there. And I'm just going to put that in a colour so you can see clearly what I did. I found the answer. We don't need any hidden detail in perspective. So I took this line back. But we do need to be able to see everything that is visible. So that was the base of the tent. That was the vertical section. This was the vertical section in the other direction. And that was the triangle, that's the back of that triangle. So that completes our question.
So the last part's happening here in 3D. We projected all of the corners of our window back to the spectator, and we were able to fill in the sides of that opening. So the pink there is the left-hand side of the opening. We've got the yellow for the top, and we can see part of the pink surface that's on the right-hand side. Now that's open, so on my perspective there's nothing showing there. But we know that we can use the window to look into the tent. So what we had to do was vanish back the bottom corners of the tent to our vanishing points in order to find out where the inside of the tent is. So we don't need hidden detail, but we did need to find these lines I'm tracing there with my mouse. And you can see that there's a bit of an edge visible inside in the tent when I do that edge there. So the part that we can see needs to be heavy to complete the question.